And then you check the microphone. The interrogation lights are better than yesterday. We're all back. It's 1 o'clock. I'm Rodney. I'm doing the intro here. Let's see. Announcements, wristbands. We're trying to conserve wristbands for people who are going tonight. You've probably heard that multiple times. Shmoo balls. We get asked to remind you to think about, throw them, buy some more for EFF. I think what you do is somebody needs to do test firings at the introducers, but do it in the next talk. No, start with me. Do the next talk. Anyway, and that, not everybody, but one. We had a few token targets we were lining up for you. Anyway, we want to make sure the Shmoo ball mechanism works. We wouldn't want to, Billy is not going to say something lame. Trust me. But when somebody else says something lame and you want to use one of these things, you should get ready. So anyway, Billy Hoffman, innocent face, really fucking scary hacker. It does what it says in the back of his business card that he takes at DEF CON. I'm sure he's got some frou-frou title for his day job. Yes, and he's going to tell us why JavaScript is really scary. Go for it, man. The books. We have book giveaways.
Do we do those before or after? Are these for good questions?
Well, now that you asked the question, you get
Do I get a book? Was that a
no,
good
you
question?
get to give away a book. Actually, you get to give away 2 books. Do it for good questions. Do it for some intelligent reason.
Okay.
I'm sure you can think of something. And is everything still working? Kicked a cable.
Yeah, it's okay.
Okay, fine, cool.
The light's still on.
Oh, yeah. Kill the speaker's PC and then walk off the stage. That's really the right kind of intro, right? Anyway.
I did, in fact, have a laptop covered with vodka and Red Bull about a week ago, and it still works. So I think it's going to take more than Rodney kicking it. So, hi, my name is Billy Hoffman. I work for Spy Dynamics, where I do have the frou-frou title of lead researcher, which basically means I spend about 1 day a week on pen tests and 4 days a week trying to write multi-threaded web crawlers and web vulnerability scanners and fun things like that. So today I'm going to try to focus on JavaScript malware and where we're kind of going with this. And the title is very tongue-in-cheek. First of all, anybody here know what Grey Goo is? Yes. All right, you get a book right here. You know what it is. That's good enough. So here, you can come get it now or later.
Runaway nanotechnology.
Yes.
Grey Goo tomorrow.
So JavaScript is very much a client-side programming language that's largely misunderstood by the public. It can be used to create incredibly malicious, cross-platform, and self-replicating software. Grey Goo is a hypothetical end-of-the-world scenario involving nanotechnology, in which out-of-control, self-replicating robots consume all matter, destroying life as we know it. Now, I'm not saying JavaScript's going to do that, but I'm saying in the last 2 years we have seen JavaScript go from stealing cookies and popping stupid alert boxes to port scanning you to doing key logging and mouse gesture grabbing, all sorts of phishing attacks. Hopefully by the end of this you will stop thinking of cross-site scripting as JavaScript and start thinking of it as code execution, because that's what it is. Yeah.
So I know we've seen actual implementation of keystroke logging and a couple other functions within JavaScript in the wild. Have you actually seen JavaScript in the wild that's doing port scanning and being used as a way to explore internal environments?
Yes. Yeah. So this is JavaScript nastiness circa 1990. Who didn't ever try to catch the monkey, all that little crap about popping it up, trying to make everything your home page, banner ads everywhere. It was more annoying than everything. This is the scape in 2006, 2007. We've got port scanning. We've got things that'll log pretty much everything you do. We've got self-propagating malware. We have things that'll steal browser history, things you search Google for. And a lot of people say, why JavaScript and why now? Why didn't we see all this stuff, ago, the Web 2.0 thing. Everyone talks about nothing about Ajax, nothing about the stuff we're seeing here is new or interesting. But what is new or interesting is Microsoft got off their ass and wrote a standards-compliant browser, thanks in large part to a bunch of hippie programmers, and I salute you, the Mozilla Foundation, because you brought innovation back to the browser market. And so we now actually have browsers that render JavaScript appropriately across multiple browsers. We have DOM manipulation and eventing. It was all different back in the day. Cascading style sheet support. Horrendous. And your average person still had, a Pentium 1, low-end Pentium 2, probably a 56K dial-up, pretty slow on processing power. As soon as it started to load like a Java applet or Flash, your mom's machine ground to a halt. So Ajax and kind of Web 2.0 is succeeding right now because it's cross-browser. Well, this is now the time for malware as well, because you now have a homogeneous platform. We've got same browsers, irrespective of the device it's running on. I mean, I cannot wait the iPhone. You've got a full-blown Safari implementation in your pocket. Oh, I'm going to have fun with that. There's so many cool things that are going into all sorts of places. Most people don't even think about, different types of devices. And JavaScript is much more powerful than it was, say, 2, 3, even 4 years ago. It's a complete, fully object-oriented language. It's extendable. It has this weird thing called prototype-based inheritance, where basically I say string.prototype and just add a new function to it. And then every single function or every single instance of a string, even those that have already been instantiated, I just extended them. And you can actually override like default constructors and do all sorts of things like that. And basically the language will let you do anything you want, and there are huge security implications as you start getting into JSON. It's kind of outside the scope of the talk, but it's very, very powerful. It also has dynamic code execution, so kind of similar to Perl or something like that. You can actually modify itself in runtime, so it makes it to write polymorphic stuff. I actually did a little bit of work about a year ago on writing some Perl code and some JavaScript code that, because both Perl and JavaScript have similar functions in eval, I actually wrote something so that if you gave it to a Perl interpreter, it would interpret the Perl code. But if you handed the same code to a JavaScript interpreter, it would execute the Java code, or JavaScript code. And it was all compressed and self-encrypted, and basically made it a pain in the ass to try to signature it. Regexes, not that they're anything nifty. The really rich interface with the browser is key, because anything that JavaScript can't do, Flash can do it, applets can do it, other browser plugins can do it, and so you can just shell out and command and take control over any other browser plugin that's present. And they have a large number of networking features built into it. That's a chart none of you all are going to be able to see, so let's move on. I tend to talk kind of fast, and I am rather hopped up on Red Bull, so if you all have any questions, please feel free to interrupt me, raise your hand. Get a book. All right, so cross-site scripting in Ajax. This has been something that's kind of cropped over the last year and a half. Cross-site scripting is essentially I'm injecting script, JavaScript, or VB script. Don't forget about it. We've actually seen a rise in VB script like attack payloads, which is really kind of funny when you think about it, because I thought even Microsoft has abandoned it. But so cross-site scripting is I inject some type of script or interpreted languages into some type of web browser. And remember, you all are Times Man of the Year. Right? User-defined content, user-supplied content, all of these are good things, so it makes it very easy to find cross-site scripting vulnerabilities, any place to execute your own code. So these scripts get executed in the user's browser, exposing them to all sorts of threats, session hijacking, information theft, content manipulation. I love telling this story. In fact, I could just show you. Yeah, why not? Okay, so my mom's birthday is every fall, and so I went ahead and I like to try to surprise her. So let me see here. Oh, this is going to be slow, isn't it? All right, we'll sit here and wait. So my mom happens to, she reads a lot of CNN. She likes it a lot. So I decided to, try to find something in CNN that I could try to make her day. Where's business? Business. All right. So this is just kind of illustrate, right? Cross-site scripting's been around for like 7 years now, and even the big guys don't get it. So let's go ahead and throw a stock tick symbol in here. And we'll actually come back to this in a minute and why this is important. Please don't patch it. Please don't have it patched. I'm going to look really stupid if this is patched. Oh, close. Closer. Let me just try something here really fast. So I wanted to surprise my mom for her birthday, and so, yep, there we go. All right, so I can, in fact, render HTML. So I wanted to surprise her for her birthday, and so what I did is I went ahead and I found this cross-site scripting vulnerability in CNN, and I wrote it so one of the things JavaScript can do is rewrite the page, which sounds kind of lame, right? Until you're a mother and you get an email from your son saying, hey mom, go read this story on CNN, see cross-site scripting, on CNN about Bob Woodward's writing about what a good mom you are. And sure enough, I had a news story, bylined Bob Woodward. I just reflected JavaScript through the query. And it rewrote the story and had a picture of mom, with a little CNN watermark. And I said, it was all about mom's birthday. And I played it real serious. It was, like, sources close to the investigation says she makes an excellent breakfast and things like that. So you can have fun with this, but there is, in fact, a reason I'm showing you this. CNN already knows about this. It got posted on a forum like months ago, so I don't know what's going on. But anyway, we're going to come back to this because you'll see this for all sorts of things throughout the talk. So, but just bear in mind, this is very present even today. So we've got key logging, screen scraping, and with AJAX, cross-site scripting can make hidden requests in the background. Well, why does this matter? Well, these are two HTTP requests. I've used this slide before. And the only difference, I'll tell you right now, between them is the referrer header. Because the first one I actually used a bookmark to get to Google Maps, and the rest of it, these are all AJAX requests. The browser makes no differentiation when it's sending an AJAX request or something done by and something done by the user. This is very interesting because the server cannot tell whether a machine did an action or a human did an action. Okay, not too interesting when you think about MySpace. Very interesting when you think about financial systems. Prove to the SEC that you didn't sell that stock because your browser did it. How do you know you didn't do it? So AJAX really amplifies the damage that cross-site scripting can do. This is going to be a reoccurring theme. Cross-site scripting can essentially make requests. And AJAX, right, it's all sexy, it's all hidden behind the user. You don't even know what's happening. Well, that double-edged sword is going to swing back and hit you because you can't tell you're getting exploited. There's basically no visual indicator on the browser except for if you're looking real closely, the status bar is going to be flickering kind of quick. Happens in the background while you're using the computer, and the cross-site scripting can read the response and send derived requests. Looks something like this. You visit a page, some cross-site scripting goes down, and then behind the scene, it starts visiting lots of pages and doing all sorts of nasty things. Well, one of the things it can do is self-propagate. Cross-site scripting payloads can now autonomously inject themselves into other pages. So it's very easy to re-inject yourself into the same host. This is like the Sammy worm and some of these other things. This got talked about a lot at Black Hat. This is the foundation because H.D. Moore actually had a really good analogy. He had something about when he was talking with Dan at Black Hat about, it was something about like villagers or Pacific Islanders and like you can infect them with eventually everyone on the island will burn out and die, and that was kind of like cross-site scripting. You could reinfect the same host again and again, but it was very difficult to hop hosts. Well, we can hop hosts now, and I'll show you. But basically, I can now send very complicated HTTP methods to accomplish this propagation. There's no hard refresh. Can't even tell what's happening. And so this guy named Sammy decided to have some fun with it. And you know, this isn't necessarily the latest breaking news, but this is by far one of the coolest hacks I've seen, and I make my living looking at really cool hacks. So this guy figured out a way to get cross-site scripting into his user profile on MySpace so that when Beetle came along and looked at Sammy's profile or something, he went ahead, JavaScript got downloaded to his machine, started running, and started sending requests back to MySpace. Now, of course, the browser tries to be helpful, and it automatically slaps cached authentication credentials and cookies and all sorts of other fun stuff on there. Yet another reason why you should never check that box that says remember me. And so from MySpace's point of view, Beetle went ahead and looked at Sammy's profile and then said, hey, I'd like to update my profile. MySpace came back and said, are you sure you want to update your profile? And it actually pushed down this little randomly generated hash that you had to submit back to it, which was pretty nifty. Unfortunately, JavaScript can read the response. Used a regex, pulled it out, and said, no, I really want to update my profile with some JavaScript code that's going to self-propagate. It also added Sammy is my hero to the end of it. Kind of funny. Think about this in a bank, okay? So ignore social networking and propagation. Think about cross-site scripting in a bank, and I can think of like 3 off the top of my head that have this. So, and they're all sequestering it. I'm not going to show you it, but this is a problem because now, especially a lot of people who they'll have different subdomains, right? They'll have like secure.bank.com and www.bank.com and things like that. But if you're accessing like the say the bill pay stuff on secure.bank.com, if you replace secure with www, it almost always works. They're pointing to the same web root, even though they're different separate subdomains. And a lot of times the SSL the certificate will be for the whole site. So whenever I'm hacking into a website or I'm watching hackers break into a website, the first thing they do is they slap a little S onto the end of HTTP. Because unless you have your backend systems architected pretty well, a lot of times your IDS can't tap it. A lot of times just people don't think about it. They'll have their SSL concentrators in a different place or something like that. I've actually had people tell me SSL is web security. I know Jay, you've probably had somebody say this to you too. We've got SSL, we're safe. SSL creates an encrypted tunnel that no one can listen in on. And if you want to learn more, I'm sure Rodney could tell you a lot. But what part of no one can listen to it unless they have the keys don't you understand? Your IDS, unless it has the keys or it's behind where the concentration happens, normally I can go right around any sort of web app firewall or something you have just by using SSL. It was a secure server. Of course, that's what the S stands for. We are pretty nasty. So let's go back to the bank example here, though. So I put cross-site scripting into a bank, and I don't even need to put it into, say, get it persisted like Sammy. You know, I just go ahead and I find the search engine. Search engines are notorious for this. You throw in some gibberish, and they come back and say, your search engine for blank was not. In fact, right there, we saw it in CNN. You know, that blank is an unknown stock symbol. Well, by reflecting it back to me, I can now execute the script. So this actually, a guy did this to PayPal about 3 months ago. There was a cross-site scripting vulnerability in PayPal. First of all, anybody here in the phishing industry or does stuff? Is Lance here? So here's the thing with phishing, right? Everything about phishing, the phisher's job is to convince you you're at the bank's site. And all phishing relies upon proving that you're not at the phishing, that you're not really at Bank of America. You're at a phisher site. So what you can do is if you find a vulnerability, a cross-site scripting vulnerability on bankofamerica.com, I just rewrite the page and put my own login prompt. Check the SSL cert. You're at bankofamerica.com. That nifty little reputation thumb up, thumb down thing, that nice little green banner bar at the cross for IE and Mozilla 2.0. Yeah, you're at bankofamerica.com. But the thing is I was able to change the content of bankofamerica.com. So this phisher actually found this in PayPal, and the guy simply rewrote. Oh, really? Of course. It's protected. I love the ones also where they're like, choose a picture of your dog, and then, because nobody can man in the middle that and just serve it back to you. Anyway, so the pictures, you know, it's all about trying to find it. So this PayPal guy actually injected cross-site scripting into PayPal, but what he did it for, Matt, why are you out there? You should be in here. This is Matt Fisher. You all should go listen to his talk. He's an our spy guy. He's a web security ninja. I pale in comparison. Now he's hiding. But anyway, this PayPal guy, he used it to rewrite the page and say, I'm sorry, our transaction servers, this transaction server is down. We will redirect you to the new site, and redirected you to some site in Russia. And the good is like, wow, I'm glad that guy was stupid. But yeah, the guy who likes to have a little bit of fun went, oh my God, you had them by the balls. What were you doing? So back to the bank, right? So I get cross-site scripting in the bank. I use Ajax. First thing I do is I grab your account balances. The next thing I do is I go ahead and try to submit a wire transfer. Now, almost always it comes back saying, are you sure you want to submit this wire transfer? But of course, JavaScript can see all the responses, and so it rips out any one-time tokens or anything like that, sends them on your way. The browser tries to help you out by adding all these things for you. A lot of times, like for Wachovia, for instance, won't allow you to transfer money to a non-Wachovia account through their website, but they do let you pull up the last check that you wrote. Does everybody know what the magical thing is on the check that you last wrote? Routing number. And so, in that sense, I've got your routing number, account number, and I've probably got your home address too. So, just out of nowhere, I now know where you live, and you better believe I'm going to start probably run by box and start trying to pull things out of it, because I bet you're going to be ordering some new ATM cards in about a week. So, port scanning with JavaScript. I want to go through because you guys want to see the cool stuff, and I want to show you the cool stuff. So let's run through this. Port scanning with JavaScript. You know, nobody ever really thought this was possible. JavaScript can make HTTP connections, but it normally can't see the response. Ajax can see the response if you're talking to the same server you came from. So if the JavaScript came from secure.bank.com, it can back and forth to secure.bank.com. And like I said, a lot of times people have the web roots all pointed to the same thing, which is how you can get screwed. A lot of times you can't see the response, but this isn't always true. With images and iframes, you can kind of see a response. You can detect whether it was successful, you can detect whether there was an error, and you can also use a timeout. So basically by using timers, error events, and timeouts, that was talking too much, but basically it's a side channel, and you can basically find out the presence of arbitrary HTTP servers on any host you want, including intranets. So it works like this. First thing you got to do is implement ping. Well, there's this lovely object called the image object, and it's got an on load and an on error event. So you set these two, and you set the source of the image to the website you want to ping. Now, if there's nothing there, it immediately closes the port. It fires an on error. But if you do an IP address and there's nothing there, and there's no system, it just hangs. until it times out. So you set a timer. If the timer fires, you know there's nothing there. If the on-air event fires, then you know there's a server there. You got ping in JavaScript. Next, we got to detect whether there's an HTTP server actually listening there. You know, we could just be banging away against an FTP server. Well, we can use the, like we said, the image on air event will fire even against non-HTTP traffic. So what we do is we go ahead and we point an iframe at it. Iframes have this lovely event called onload. I won't be able to see the content in that iframe if I'm running, say, in CNN, and I've used a cross-site scripting vulnerability in CNN to start opening iframes into internal hosts of yours to detect the presence. I won't be able to see the content, but I'll know when the iframe's done loading. And if it's never done loading, it never actually talked to an HTTP client or an HTTP server. So if the onload event fires, there's an HTTP server there. If it doesn't, there's some other type of server. Now let's fingerprint it. Let's know what's there. So we fingerprint by requesting images that are unique to the web or to the application. And we use the image object for this. We basically point it, and you know all those little powered by PHP, Apache's got a bunch of banners installed by default. Yeah?
This will use any cache credentials so that if your internal sites require credentials that they're already stored in the web browser,
Yes.
it'll come up just clean, right?
Yes, which actually when we get to the next slide about how I'm going to use this to reconfigure your router is very interesting. But you didn't see that coming. So anyway, basically I use the image onload event and I say, get me this image over here. Let's fetch it, and then I'm going to check the dimensions. So right here, I went ahead. Apache by default has that lovely icons directory, you know, for everybody who needs a little fun picture of a tar file. I go ahead and I fetch that file, and if it comes back and it's 26 pixels by 22 pixels, you're running Apache. If I come back and I get pageerror.gif, you're running IIS, and you're running IIS 5 or IIS 6, not IIS 4. And you can actually do this checking the existence of cascading style sheets, different things like that. So it's possible to fingerprint. Oh, I actually didn't have a slide in there. So the next step is I can actually do like blind posts and blind gets and actually send requests. I can't see the response, but I could send maybe a post to like your little Netgear router saying, hey, turn on wireless and turn off web. And if you're authenticated already, it'll work. And if you have, I can actually send default credentials too, and it'll work. So I actually can get into your corporate network through the browser. I now have JavaScript which controls the browser, and I'm forcing the browser to connect to things inside of your intranet and do nasty stuff. Stealing JavaScript history, this was kind of cool. In the beginning, links look different if they're visited or unvisited. Well, there's this fun thing called styling. So normally the user agent would do this. We've all seen the little blue and the purple. Well, cascading style sheets allows users to create funny links. Well, JavaScript is able to interrogate the style on any tag. So what we can do with JavaScript is we can dynamically create an anchor and point it at /. And when the browser renders that, it goes ahead and applies the appropriate style, be it, you know, pink or purple or whatever I define in the style sheet. And then I use JavaScript to check what the style is on that link. And basically I can find out what websites you visited. It's kind of funny. It's actually in the W3C standard that it's possible that cascading style sheets could abuse these to determine which sites the visitors have visited. But I guess it's kind of like, you know, WEP, and they decide to C4 anyway. I mean, this is there, but nobody really paid it heed. So like we said, we dynamically check things. We look at the style. So now I can find out where you've been. You got to think of this, though, as a giant hash table, right? I can't enumerate through and say, show me everything that Press Mike has been visiting today. You know, I can't see that, but it's a giant hash table. So I can say, has Press Mike visited, you know, girlsgonewild.com today? Has he visited, you know, whatever it is that Press Mike visits? Discuss anymore. So I can ask it all the sorts of yes/no questions that I want. Lucky depending on how you're looking at this, I can do this thousands of times a second. So if I have a question, I just ask. This is interesting. We probably can do some more fun stuff with that. Specifically, we're detecting very specific URLs. Sometimes URLs can be different for everyone. When you go to Amazon, right? Amazon immediately 302s you to another page that has in like the path of the URL a little token, in case you've got cookies turned off. So everybody hasn't actually visited the same sites, even though they're seeing the same content. They haven't visited the same specific URL. Well, what else can you do? Well, these are some Google queries, searching for snakes on a plane and porn and spy dynamics and acidus. So all of those look actually pretty similar. In fact, if the user's been to the results URL for a search query, they've searched for that query. So conceivably, we could just check whether I've gone to google.com/, search Q equals SPY Dynamics, and if I have, then I just search for SPY Dynamics. I know I have. So there's a few problems with this, but they're manageable. First of all, how you get to the results page varies. Like if you actually click the Google search button as opposed to just clicking enter, it changes the URL. Whether you're already at the top of a page you've searched and you do a search, the URL is slightly different. You see in this bottom thing, there's this little LRE. It's an empty thing. There are just all these random parameters Google throws in. But remember, we can only ask very specific URLs. Even if parameters are out of order, they'll be different. So we have to check them all. Also, letter cases causes a problem. SPY Dynamics is a different URL than SPY Dynamics capital S's. Diffie-Hellman, you also have a word order, which can also be a problem. So if we had to brute force all of these, how long would it take? Well, given if I have a query with X words, there are 2 to the X of whether it's uppercased or not, the first letter. There's X factorial number of ways to sort them, and there are Y unique results for these. Each page, there are like 3 different ways to get there. So basically, to search for a 4-word query to see if you've searched for some variation of secure handshake Diffie-Hellman, I have to search over 1,000 URLs. And also, what happens if they didn't use Google? They might be searching on MSN. Well, wow, I don't have the slide in there. Actually, this is unbelievably, you can do this. If you go to spydynamics.com right now, a little proof of concept. You can type it in. Basically, I can do thousands of these lookups a second, so it isn't a problem. Once you get above about a 6-word query, though, you start dealing with about 75,000 permutations. And on Firefox pops up that nice little helpful dialog that says, this script appears to be running for a long period of time. Would you like to stop it? IE just kind of locks. So go figure that one. But needless to say, I can steal your search engines. And I know I'm running through this kind of quick. All of this stuff is on SPY Dynamics' website. You can check it out. We've got proof of concepts and white papers and other fun stuff too. So what's kind of the future with JavaScript malware? Well, we've talked about kind of cross-domain, cross-site scripting worms. So MySpace, and there was a worm called Yammer that hit Yahoo. There have been a bunch of these. They could never hop hosts, right? Because Ajax can talk back and forth freely, but if I want to just send, it's almost like messages in a bottle, right? I just put exploit into a bottle when I throw it over at this site. I don't know whether it works. There's no way for me to get feedback unless my exploit includes a callback. It's like everybody does this with shellcode, right? You've got something to phone back home because probably, there's maybe a firewall or something. It has to connect back out to you. You can't connect back into it. So it's always been kind of a question then of if we know we can kind of throw these things, we can't see the response, how do we know where to look for targets, right? Like let's say I find a pretty good remote command execution vulnerability in like PHPBB, of which there are many. So how do I find other sites? Well, Google unleashed this thing called the Ajax Search API, which actually has nothing to do with Ajax whatsoever. They use you basically include a JavaScript tag. You say script, and the source of this JavaScript file is google.com, the query you want to run, and the function that JavaScript should call when it's done loading. So it's kind of cool. But basically, I can go ahead and search for Google. Cross-site scripting can, once it gets on a new website, on a new host, can go ahead and ask Google and use random words and say, hey, Google, find me more sites that have powered by PHP 2.1 and kitties. Or, shamrocks or something. I don't know. So I can now find Google. I can now use Google to find vulnerable hosts. And then, like I said, we can use kind of these blind gets and blind post methodologies to attack these new hosts. And so we can actually hop, which is interesting. There's also kind of this cool thing I've been working on, this cross-site scripting and Perl hybrid. So it uses Perl to hop hosts, but if for some reason it tries a couple of times and it's been unsuccessful, it goes ahead and just kind of, it's almost like, what are those things, sea monkeys? They're like sand, but you put water on them and then they're alive, but then you go away on vacation and all the water dries up and there's sand again, but you put more water on them. Those things freak me out, actually. I don't do that. But that's kind of the theory with this, is I'm going to go ahead, if for some reason with Perl I can't actually get out of your box, I'm going to go ahead and inject myself into your HTML pages as JavaScript and sit there, and then I'm going to get downloaded to people's machines, and then I'm going to try to do, say, like the Google Search API or something like else to try to get back out. It's pretty neat. Use Perl to spread from host to host, and like I said, cross-site scripting kind of is a seed around a shell, or a seed to kind of store itself when it can't get off the host easily. What we're really trying to go here, though, towards is a step towards a JavaScript web crawler. I mean, why have Google figure this stuff out for you? Google could always cut that off. The ideal thing would be I could just crawl a website. You know, I'm at CNN.com. There's some JavaScript code there that gets downloaded to your machine, but I could have it crawl, you know, Bastille or something. You know, so kind of the neat light at the end of the tunnel is, can we get JavaScript to completely blow away the security model and actually crawl third-party sites? Now, here's the funny thing. You're not supposed to be able to do any of this stuff. You shouldn't be able to port scan. You probably shouldn't be able to, you know, read search history. No one probably ever considered brute forcing to steal Google search queries. But JavaScript is powerful enough, and machines are powerful enough now that you can do it. And interestingly enough, I'm sorry, anybody here use Opera? You guys are screwed the worst. Opera's good, but the reason you're screwed the most is Opera has the most incredibly efficient JavaScript interpreter there is. It's something, I don't even know what these units were. I was reading this article, but this guy ran some benchmarks, and Mozilla came in at like 2100, and IE was like 19, and they kind of, or 1900, they kind of oscillated back and forth. Opera's was like 300 something. You know, the number of it was like the number of microseconds it took it to do so many DOM operations. It was ridiculously fast, which means that this JavaScript can only screw you because it can run so fast. So actually, your grandma on the, you know, the old Pentium 3 is actually pretty safe. Well, no, God, no. Let's hope not. Oh, that actually brings up another thing. I was talking with a couple of folks the other day, and I always get so depressed. I mean, I get really excited talking about this stuff, but then they say, okay, Billy, how do I protect myself? And then I get depressed, because really there's nothing you could do. I'm sorry. You're the end user, and all of these flaws ultimately are things that are wrong with websites, right? I'm not like doing some crazy Metasploit stuff where I'm exploiting your browser in fun and interesting ways, right? You're allowing me to do this. JavaScript is code execution. Supposedly it's in a sandbox, and supposedly it's not supposed to be able to do certain things, but it can. And short of turning off JavaScript, you're screwed. And really, turning off JavaScript just isn't an option in these days and age. Now, there is something called NoScript. It's an extension for Firefox, which essentially lets you whitelist what sites can run cross-site scripting or run JavaScript. But that, yeah. They're all cross-site scriptable. But that doesn't work either, right? Because you might say, I love my Google Maps. I'm going to go ahead and allow Google.com to be on my whitelist. Well, Google's gotten hit with like 3 cross-site scripting vulnerabilities in the last 2 months. They had a big one in Google Desktop. They had one through their contacts list and Google Talk, and another one through Gmail. Yeah?
And it immediately fails for any user-contributed websites if you allow LiveJournal or Gotham Space or anything like that, and there's no way to specify per script or even per internal page. You just do it by domain for the most part.
Here's the scary thing, right, is that malicious JavaScript looks exactly like regular JavaScript. It hooks events, mouse overs and clicks. It goes ahead and manipulates the DOM. It makes requests, makes AJAX requests, makes image requests to off-site hosts. It does remote scripting. From a conceptual point of view, it's a very difficult problem to look at an arbitrary piece of code and say, malicious. At least with, say with C or something like that, you can whitelist certain syscalls that you're allowed to do. But JavaScript is so basic in what it's able to do, but even what it allows, you can still do a lot of nasty stuff with. And I wish I had better advice. The only thing I can say is really pressure the people who are vulnerable. I mean, Google and eBay and Yahoo, they're putting significant dollars into fixing this, and there are 2 things you should take away with that. One, if they think it's serious, you should take it seriously too. And one, they've been doing this for a lot longer than probably any of you guys have, and they don't have it right. So it's pretty hard to go ahead and really lock down a website. There are a lot of open source tools out there. I'm not here to sell you anything. So by all means, lock down your website, because I really don't want some 13-year-old end up with my bank account because somebody didn't know what they were doing when they were writing financial software. So basically, this is the same origin policy, and now we're going to show how to violate it. The same origin policy basically says, if I've got a page that opens up content from site 1 and maybe in a frame or something else opens up content from site 2, they're not allowed to read each other. They're prohibited from accessing each other's content. Well, Google Translate to the rescue, right? Or really any of these type things. Google Translate fetches pages for me and then serves them back. And if you look at the URL, it's google.com, translate, whatever, it serves the page back. So I can request content from site 1, Google acts as the proxy and brings it back, and then I request stuff through the Google proxy for site 2, comes back. Both of those are in domain, same origin policy means that they're allowed to see each other. There are lots of services like this. I mean, Google Translate happens to be an example of something that's not meant to be a proxy, but you can use it as a proxy. There are a lot of other things. I'm using one I think called, I don't even know, like I found it last night and just wrote something to it. There's one called Proxy Drop. There are a lot of these things. But essentially, anything that'll proxy or forward request for me, I can bypass the same domain policy. So this is what Jicto does. Jicto is a JavaScript web vulnerability scanner. It can crawl and audit third-party websites. So you can put some code in, your local, spydynamics.com, and that code could go ahead and start auditing, say, CNN or, our QA lab or other stuff. It can talk to third-party sites. It's based really heavily on the work of this great guy named PDP. He runs GNUCitizen.org. He came up with a way to use Google Translate in a crawler like late last year. The problem is that iframes, which are to do, and also cross iframe communication. And I use Ajax, which is a hell of a lot faster. The problem with iframes, right, is you can say, hey, I'm going to open an iframe to this, Google Translate, and Google Translate will go fetch me this. But you can't actually read the content of the iframe until the iframe is finished loading. Well, what does that mean? That means the HTML and all supporting documents. Images, Flash objects, cascading style sheets, external JavaScript files. Does anybody have any idea how big CNN.com is with all its dependencies? 365K. So if you were trying to load 365K through an iframe, it basically would take you 15 times longer than just grabbing the 22K of the HTML file, which is really all you care about. So by using Ajax, it's substantially faster. And what I'm doing is I go ahead and I use Google Translate or some third-party site to bootstrap my code. I don't even talk to Site 2 through an iframe. I just use an iframe to go say, hey, Google, or some proxy site, go fetch Jicto. And now Jicto's running in that site. Now Jicto can use Ajax to talk back to Google Translate or whatever and say, hey, fetch me this, fetch me this, fetch me this. And it's blazingly fast. So a lot of people love to say that Ajax doesn't change security. They're kind of living in the past. Ajax does. Ajax does a lot of things. People said that you could do this with iframes. Well, you can, but PDP found it wasn't practical. And nobody viewed it as a real attack vector until basically this came along, and suddenly I'm arming script kiddies, so go figure that one. Anyway, Ajax does change security. It makes things a lot faster. It lets me see HTTP request headers. Richard. I should take this opportunity to say you all should go to Security Opus. If you didn't go there, it was earlier this week, right?
Yeah, we got Friday. I got a red eye.
Oh, see, he loves Shmoo that much. It's a great con. They hold it at the W speakers, and Richard takes care of you well. So I highly suggest everyone goes to that. Anyway. Oh, really? Excellent. I think he'll be here too. So how does this thing work, right? So like we said, our JavaScript needs to be in the same domain as the website we're going to scan. So how do we do that? Well, we load an iframe to Google Translate. In fact, I did not use Google Translate. These slides are about a week old. And I point Google Translate to the site where Jicto is. And then Jicto code is now running in Google Translate's domain, and I can use Ajax, Google Translate, to go fetch any public-facing page of any site. Ajax is much faster than iframes. Now here's one of the first limitations here, right? I can only do this because I'm using Google to do kind of the heavy lifting for me. They're actually going and fetching the document and putting it in my security domain. You can't use this to scan internal sites. So I couldn't put, say, cross-site scripting inside MySpace and then use it to use Jicto to crawl and attack internal websites to you, because I actually kind of using this thing, and Google Translate has no way of knowing where 172.168.1.1 is, so it can't fetch it. Jicto then goes ahead and analyzes the response. It derives additional requests to make. Anybody here ever have experience writing web crawlers? I mean, that's not rocket science. You fetch the page, scrape it for links, throw it in a queue, keep going. Now, it actually starts getting to be rocket science when you have to start understanding things like JavaScript and Flash, but this is a proof of concept. So there are some pros and cons to this, right? It's extremely fast. There's no application needs to be installed. It's cross-browser and cross-platform, which is why I can't wait for a little iPhone. For the attacker point of view, they can now find exploits, right? The kind of the trend we saw with more traditional kind of attack tools was first we had to find stuff. So we had things like Firewalk and different ways of getting around firewalls and different ways of port scanning and scans and bounce scans and things like that. And then we started actually developing attack frameworks like Metasploit and things like that. Well, with JavaScript, we've already done the fingerprinting and finding. We did that last year. This is the year when we figure out how to exploit you remotely. And this is also weaponizable. I can put this in a cross-site scripting exploit. So basically, cross-site scripting plus Jigto plus a social networking site gives me a botnet with people coming in and out. We'll talk more about that in a second. Now, there are some cons, and the cons are you're using a proxy, and the proxy limits you. I'll actually show you some code here in a minute. This proxy did some fun stuff. But does the proxy actually forward all the HTTP headers? So if I tell, Google Translate, hey, Google Translate, go to, site.com/this page doesn't exist. Does it give me back a 200 OK with a message that says we couldn't find this? Does it actually forward the 404 to me? Do I get all the cookies? Can I do posts? Will it automatically forward the posts along for me? Also, XML HTTP request, which is the backbone of AJAX, automatically follows 302 redirects, and it doesn't tell you, which is a big pain in the butt. Because a lot of times you'll visit a page and it'll say, no, that didn't work, and they'll redirect you to some other page. And normally that other page has interesting parameters that are vulnerable, but you don't get to see it. So there are some downsides. Let's go ahead and just show, it has a very simple architecture. Basically, it's got 4 components. It's got an HTTP requester, which handles kind of negotiating with this proxy and sending AJAX requests. It's got an answer, which rips out links and rips out forms and scores attacks that were being sent. It has a controller that sits above all this, which decides how to derive new attacks. It fuzzes values. And then ultimately, you have a UI sitting on top. Let's go ahead and show it. So this is a page right here. Now, what I'm going to do, all that's on this web page, show you that there's nothing up my sleeve, is there's just simply an iframe. Thecloak.com. That's what I'm using. The cloak. Ooh, actually, you can't see that. That tells you where the code's living on the public internet. Anyway, so there's an iframe. I should take that down after y'all snatch a copy. No, I'm kidding. Yeah, well, it'll be gone before then. So anyway, all this is just an iframe, right? So all I'm going to do is when I visit this page, I'm going to pop it. Let me make sure this thing's all clear. This is where all the information gets reported. So right here, I'm going to go ahead and I'm going to fire it up. And so it starts scanning. And in fact, I'm going to open. These are all the requests Jigto's making. And you'll see it's making requests to thecloak.com, whatever. So what it was able to do was this, I'll just show it to you anyway, what the hey. Thecloak.com cloaked, and it's pointing to the site where Jigto is actually located. So now Jigto has been loaded into the context of thecloak.com. Now Jigto can make HTTP requests back to thecloak.com, AJAX request, and that's exactly what it's doing in the background here. It's still running. All those reds are 402s. There are a couple of audit engines I wrote for this. One of them, it's trying .back, .old on the end of some files. It's still going. We see right here there was a cross-site scripting attack. This is Firebug, if you all haven't messed with it. It's a JavaScript debugger, and it made my life a lot easier. So we're still going. This is going to run through. This is a test website I'm scanning, 0.webappsecurity.com. Still going. Oh, it's right near the end. This is the big thing of links where we test to see if our crawler. And it seems done. And in fact, I can check that it's done by saying, y'all probably can't see this, but pending length. Pending length is not defined. That would be a problem. Anyway, well, we saw these requests. I went ahead. This is a proxy. I ran everything through a proxy as well. So we can see that we were sending requests to thecloak.com to actually go fetch stuff from Jigto. This very first request is Jigto, and then everything after that is saying go crawl webappsec.com. Jigto is not hosted on 0.webappsecurity.com, but I was able to pull them both into the cloak.com's domain and got them to talk. So let's see what it actually found out. Jigto was going ahead and scanning all those files and was pushing the results to this other site over here. View scanned messages. So here are all of the pages that it got 200s for. This is one of SPY test. Sure our crawler stops after so many directories and different things like that. And down here are vulnerabilities that it found. So it found 2 cross-site scripting vulnerabilities, severity of 100. Let's go ahead and click that one. Bang. We found cross-site scripting. And if you'll notice the web app right, or the URL right here, oh, actually it appears twice in that page, is 0.webappsecurity.com, even though over here we're in thecloak.com. Moving back. So we've got some backup files detected. Let's go ahead and check out of these. One of these is actually cool, and one of them is lame. So let's go ahead and look at this one. Open that with Notepad. And so there's some nice fun ASP.NET, or just classic ASP. So I actually got the source behind on the page, which will normally have like, like database connection strings and things like that. Got a lot of backup files, like help.cgi.back, default.asp.back. Let's see what that one is. Probably just nothing in it. Yeah. This one just simply does a redirect to log in. So, but those were just common types of attacks. Now, I only did 2 types of attacks. Cross-site scripting, I did some SQL injection, and I was brute forcing backup file names. Standard crawlers like Nicto, which is Jicto is Nicto, but JavaScript, but not nearly as sophisticated. There are a lot more attacks that can be done here. So we went ahead and found, is this another vuln? Hope this is excellent. So we found 2 cross-site scripting vulnerabilities and like 7 of these things. Now, I'm going to run back over here to the cloaked page. The thing that I love about, the thing that I absolutely love about Firebug is it tells you how long it took for these requests to happen. So we come up here, we're talking on the order of 266 microseconds, 230, 300. Oop, that's not where I'm supposed to go. So one was 31. We see the ones that result. Ooh, that's not good. All right. Well, hopefully you can see the background. The ones that were 404s took longer to respond because the web server had to exhaustively find. The ones that actually hit were responding in 32 milliseconds. Y'all can scan that site yourself if you'd like. It's quite large. But basically, I was able to crawl and audit that site in less than a minute with JavaScript and find scripting vulnerabilities, which is interesting because something occurred to me is that this part of Jicto doesn't have to be local. Like right now, we can actually look at the, well, if this comes back up, we can look at the code. I apparently lost, acquire that network address, come on. So these 2 parts of the architecture, the controller and the UI, don't actually need to be on the client's machine. What happened is I downloaded the full thing of Jicto, included all 4 of these parts. But the thing that really that needs to be on somebody's machine is the thing that makes a request and the thing that simply parses and pulls out forms and scores attacks. Those results could then be sent to a third party, which goes in and decides what other attacks to do. It could say, you send these 7 attacks, give those response back to me. Now let me go ahead and tell this other guy in my botnet, hey, you send these 3 attacks. And then suddenly I've got distributed. I didn't do that, but it's certainly possible. Oh, good. I'm connected back. I appear to have lost that because I want to show you guys some of the code. Is this cool? Does anybody have any questions? I know I'm talking really fast. Y'all understand what I'm saying? Good. Are you scared or are you just okay? I don't know. But if you saw it, you've got about 10 minutes before it's gone. Oh, come. Oh, stop knocking me. Oh, good. All right. Well, hopefully that'll. Oh, come on. For the love of God. All right. So, does anybody have any questions so far? That should go through. Yeah.
You mentioned that because of the domain security malware, you can only grab sites that are in one domain.
Yes. Public domains.
Yeah. Couldn't you get around that if you had 2 different cross-site scriptings in the same host, where one that was operating locally would just post information onto, say, a wiki or MySpace or whatever, and the other one would just grab information through the...
Sure, but then you're not really doing anything with JavaScript. You're kind of offloading it to that other thing, which does the pushing to the wiki.
Then you could have one of them actually doing local attacks and
local JavaScript is really local, and I've got about 5 minutes here, so I'm gonna.
Okay.
We can talk about that afterwards. So, what are some advances I could do with this? This is kind of a nifty proof of concept. I hope it was interesting. So, what else could I do? Well, I could check to see if my cross-site scripting attacks work because I've got a browser, right? I've got a JavaScript interpreter. I could send the request, take the response, and throw it to eval and see if it actually executes. So I can actually dynamically build attacks and discover new vulnerabilities on other sites automatically exploit them. Say, I'm going to try this attack. I'm going to try this attack. Oh, that didn't work. They're filtering out double quote. All right, I'll use this. So I can iteratively go ahead and find new vulnerabilities and confirm that they work, and then it's wormable because I just found a confirmed cross-site scripting vulnerability on another host. So now I can jump. So now we start to see that thing on CNN or something on MySpace. It's not just MySpace or CNN that's going to get screwed. Everybody could potentially get screwed because you can now hop hosts, and you can do it a lot easier. I can do SQL injection. If it's verbose SQL injection, I can see the response. This is probably small, but it says, ODBC error converting the var, or nvarchar value tbl_products to a column. So I can go ahead and take something like Absinthe or one of these open source SQL injectors and go ahead and put it in JavaScript. So now JavaScript downloads, port scans to find publicly available sites, maybe ask Google to find publicly available sites, uses Jicto to find vulnerabilities, and then uses a JavaScript version of, say, Absinthe or a SQL injector to actually steal data and nobody distributed. So this gets really scary really quick. That was about all I had. Does anybody have any questions that's warranting of a book about cable modem hacking? Oh, surely somebody has something. I talked way too damn fast for. Yes.
You say that Ajax doesn't really change
Nope, it does.
dramatically security. It doesn't really change the fact that the root cause of the problem is still input validation.
Certainly.
It sucks on everything.
I don't want to be. Everyone says this, right? They're like, oh, web security is nothing new. It's input validation, right? Well, there hasn't been anything new in security in about 30 years, right? It's all input validation. It's all configuration. I mean, I've got a book that's called Computer Security and Privacy, or Security and Privacy in Computing Systems. It's written by this dude from MIT. It's from 1973. And in it, he talks about pretty much everything before it became popular. He talks about having a centralized system for vulnerability management reporting. He talks about having Tiger teams, because the only way you're going to find out whether you're secure is to break it. He talks about input validation. Back in the day when the computer was so expensive, if the grad student crashed it, it was worth more than the grad student's life. And that's why you did input validation, because you wanted to make sure that your program didn't get junk and crash. I mean, I don't mean to come down on you, but none of it's new, right? It's simply how these things apply to different types of paradigms, right? In the web, for example, input validation takes on a much bigger role, right? If I can throw 8 to the find dialog of Word and crash it, who cares, right? Even if it's buffer overflow, why would I do that to execute code as myself? That's silly. But if I can do that into Google Documents and Sheets, and I own the server, I win. So it's all about how these things apply to different types of situations. Yeah. Good. All right, fantastic. Yeah.
Use this in conjunction with Grease Monkey at all?
I don't really like Grease Monkey. Grease Monkey is a way of tweaking your browser security settings so ridiculously low even IE would complain at you if it ran in IE, and I think Grease Monkey is actually a bad idea, and I don't use it. But why would I need it? I could do this stuff with vanilla JavaScript running in a sandbox. So I'm not knocking it. It exposes you to all sorts of risks you don't need to do, especially with their cross-domain XML HTTP request. It's just silly. I believe Rodney's up here, and I didn't get a Shmoo ball thrown.
No, I'm not here to give you the hook. I'm just,
Excellent.
Somebody's going to help harass you. These people are way too passive.
I know. I don't know how to take that as feedback.
They're taking notes.
I hope so.
The
Well,
internet's going to melt tomorrow because of you.
I hope you all enjoyed it. Thanks a lot. You guys come ask me questions if you want. There's my email address if you all need it. Yes.
So the issue of speeding up a script inside an environment. So you've got the search engine within an internal environment, and you've got to be able to get embedded into the internal search engine so that you can start scraping it.
Right.
So you've got a lot of using Google appliances.
Right.
My thought was, take the cross-site scripting, you set it up as a custom search string in the internal. So you basically find the internal search engine, you start running cross-site scripting through it, and you take advantage of the fact that it's going to cache whatever you deliver to it. You then take advantage of the fact that you've got the Firefox web browser, or not web browser, web server.
Oh, the one that thing just cracks me up because we need to have web servers running inside of our web browsers.
Can we unplug you?
Yeah, sorry.
If you add in basically the equivalent of Google bombing to this, you have the ability to cache a query on your internal search engine, drive up its priority such that it's the first response for anything that somebody's going to deliver, and have it generate instantiated out of your own web browser.
can, but we have a Google appliance at Spy, and I have bashed my brain against it for months on end, and it's pretty secure.
I don't see this as a way to compromise the clients. I see it as
Right, but you gotta get in. Right, it's a good. I mean, you want to get it cached by it. It normally filters and won't reflect it. It won't. It'll filter stuff out.
so I see fundamental problems with the reinforcing the all possible sites you're going to. You're going to miss the entire.
Katrina.
Where's that purple bag? Thank you.
We're getting technical with video cables and things. It'll be just a minute.
I have the cable, so I can go back to that.
Which is a good thing because the IBM isn't.
Yeah, I'm glad I've been carrying this one all day.
I'm glad you did. Thank you.
That's used for it.
Yeah.